Now the floor is open. Who wants to raise question? Please, yes.
Well, thank you for the presentations. I have actually a question to both of you. So something which didn't pop up and which I see in my daily life as one of the key challenges when working with machine learning algorithms is how to formalize expert knowledge in a way that they can be exploited in learning algorithms beyond providing training data. I mean, we can all provide training data. It's a very time-consuming process. But what are good ways for incorporating expert knowledge so that systems can learn with dramatically reduced training data? Because that's what we as humans do. Well, if we study a new subject, we first take a textbook and study the textbook, what other people have formalized and learned, and then we try on our own and expand our knowledge by trying things out, for example. So how do you see this? Is this a challenge from your side as well, and what are your approaches towards that?
Thank you. Please.
Okay, this question of hybrid modeling is, of course, a very important one. I mean, we do not always want to start all programs or machine learning programs from scratch. And I've said at the outset that design theory becomes very important. So the question you're asking has to do with that. How do we go about designing our goals? Is this just an informal way? We have to come up with formal goals. So any help that we can get from expert knowledge in setting up the goals, and of course in maintaining the alignment of the evolution of the reward systems and the goals in the machine with those goals is a very important question. And I think in your talk we may see an example of where we bring up such hybrid technology into work in connection with robots in the agricultural field.
Thank you. Please, Pasquale. Yes, please. You have to push.
There we go. Sorry about that. I just wanted to ask, with respect to the idea of a reward system, does that presume that advances with respect to this type of machine learning would need to be predicated on a form of commensurability, such that we could compare any given state of affairs as either being better or worse than another? Because I'm just thinking about, does the machine need like a scoring of the new reality that it's created that is a simple binary, either better or worse, or is there a certain multidimensionality that could play into these reward systems?
I think it's a very important question, as it points to say the security of AI solutions in the reinforcement technology. Where one of the dangers, of course, is that we come up with, let's say, proxy goals as rewards. The machine might very well adapt in a way that we would not like, in corrupting rewards. So fending off corruption of rewards is an important question.
Yeah. Thanks. The last question is from Marcos, please.
Yeah, thank you very much. So do you think there could be a general induction style solution to the ethical question, which of course the MIT project at least suggests? Or do you think, because there seems to be this problem that what is the training basis for it, right? I mean, induction, so what's the rule? So it doesn't seem that human normativity, I mean, there's a good argument against why this should be possible, the normativity being distinction, right? I mean, what humans ought to do is not identical with what humans do, otherwise they wouldn't be blameworthy, so no data of what humans do is evidence for what humans ought to do. I mean, that seems to be a problem, right? Or how would you tackle this? What's your intuition or even knowledge?
I think the MIT project is much more modest. They tackle the trolley problem by crowdsourcing the human judgments and taking statistics on that. I think there is no inductive solution to the problem of whether to hit person A or person B. And so there's no legal answer actually. We are not supposed to discriminate. So what are we asking the machine to do? Take a guess or take a random decision? So we're still very much at the outset there.
Thank you. Joachim will conclude.
No, a quick question. You defined measures of intelligence as agents' ability to achieve goals in a wide range of environments. But we also change environments. In that definition, environment and in the system you presented is fixed. Can you elaborate?
Yes. No. I did not mean to have to ask the environments to be fixed once and for all, but the environments, of course, change with the actions of the agent. So the environment being modeled as a Turing machine in a very universal way. Just asking that the environment be computable for us to be able to mimic, because after all we have to come up with an algorithm, so if it's not an algorithmic environment we cannot model it, is all we ask, but it can change.
Okay, thank you very much. I think that we